Okay, folks ready to get started? Okay, so for the next part, I'm going to be going a bit deeper into how routing works. So I'm using a lot of material from a talk that my friend Daniel, who's also the creator of FN, that he and I gave at Haskell user group, New York Haskell user group 3 years ago. Anyway, so you can see his full talk. The slides are up at this location, and I'll paste that into Discord too. He explains it like it's the same example, but he explains it a little bit differently. He uses a lot of like lambdas to explain it, and I just am basically doing the same example. So here's the puzzle that I presented earlier of these typed routes. Does anybody have any just like ideas or of how this works? Or thoughts on how it might work? Okay, I'll just get into it. So let's just like look on Hackage and see what the type of that little arrow operator is. And it's really scary. Know what that is. And it even says here, Daniel added the helpful note that this type is not particularly illuminating as it uses polymorphism to match route patterns with varying numbers and types of parts with functions of the corresponding number of arguments and types. So if we want to understand this type, we have to really understand how you could use polymorphism to do that. So let's start with a very simple example that uses the same concepts. The example we're going to use is based on like the C function printf. So we have like some variables, and we want to kind of stick them together with some strings in some format. So in our printf function, we're going to have some format string on one side, and then we're going to want a function that tells our arguments or format that string. And in that way, it's going to be kind of like how the routing operator has a bunch of routing patterns that need a function that says like what part of that pattern. Can you see how those are kind of the same? Okay. We're going to have a function, and then we're going to have all these little formatters. We're going to have 3 formatters. C is just the string stays the same. E is going to be an integer, and S is going to be a string. And if you go to continuations, then you can kind of see these examples. And if you run them, you should get this output. And you can see that this works the way that we have over here. If you say printf with just a string that doesn't need any formatting, it's just the type I. If you say printf and you give it something that or say that a number needs to be formatted, then you need to provide that number before you can get the output. If you say printf and you give string is expecting a number and a string, then you have to provide a number and a string before you can get I/O. Does that make sense? So it's kind of like it's for like. So we have a couple tools in our toolbox, polymorphism and continuations. So polymorphism is the idea that you don't always need to specify a concrete type. And some things can just be any type. So if we didn't have polymorphism, then if we wanted to say, here's a function that takes whatever you give it and just returns back the same thing, you'd have to define that function over and over again every time you wanted to use it for a different type. So if you wanted to use it for an int, you'd have to make an int version, you'd have to make a string version. If you wanted to do that for functions, you'd have to make one for like every different function you could ever touch. So luckily, instead, we have polymorphic types, and we can just say, this is some type A. We don't care what type A. Whatever type of thing you'll give us, we're going to give you the same type back. So if you give it an integer, we know that the A in this function is an integer. If you give it a string, we know it's a string. If we give it a function from integer to integer, we know that the A is going to be an integer to integer. And that's a type of polymorphism. So use that. We're also going to use a concept called continuations. So printf is going to be a function that is waiting for a function. It wants a function to tell it what to do with its result. So you end up with a type that looks like this, where it has this like ending type that's like very that's like polymorphic. It's like it could be anything. So if nothing needs to be formatted, it'll just be IO unit. If one string needs to be formatted, A will be a string to an IO unit. If a string and integer needs to be formatted, it'll be a string int IO unit. Because our format say what to do with those arguments. Everybody still with me? Okay, so the question becomes, how do we make that format function? So the first one that we're going to work on is constants, or like the constant string, the string that doesn't change. So if we say printf c hello, we want that to just be IO. And it's just going to print hello. And just as a reminder, this is what the type of printf is. So when format is, actually I'll just use my mouse. So when format is C hello, then its type, then the type of A here is IO unit, right? Does that make sense? It prints hello, so the type is IO unit. So this becomes sort of like the concrete type of this function when it's applied that format. So we can just copy this whole type here, that's the type of format, and say that that is the type of C. Well, of the C after it's applied to a string. Okay? So, but that's too specific because it's type IO, so it can only, you can do with that is IO actions. Like sometimes what we want to do with our formatted string is we want to combine it with strings before we print it out. So this is not going to work. So the actual type we want to like take all those IO units and make them less specific. So we're going to make them just A. And now we have the type of, for what we want for this little formatter function. Does that make sense still? Okay. So now we actually have to say what does that do? So we know that C has two arguments now. It has a string and some function. So we can like list those arguments out on the left side. And well, we have a string and we have a function from string to A. We know we want to end up with an A. Can anybody guess what we're going to do? We're going to apply that function to the string. So that is the definition of C. So if you actually want to try this out in GHCI, what you can do is import continuations. Oop. Oh, it's already imported. Cool. Great. So I can say, can everybody see this okay? Yeah, I'll make it a bit bigger. Okay. And so it takes two, so it also needs some function to say what to do with it. So we can say put string and then I'll print it. We can say ID and it'll just return back the same string. We could say reverse, it'll reverse the string. We could say length, and all of these things are obviously a different type. So the A can be anything. Does everybody still with me? Okay. This is like the deepest stuff I'm going to do in this workshop, so definitely let me know if I'm like getting too abstract. I'm trying to keep it real concrete. So yeah. Okay, so let's try another one. And this is very similar. So we have, if we say printfs, we want it to expect a string to IO unit, right? We want to be able to, you need to give me a string before I can print anything out. So again, we're going to like kind of just put those concrete types into the type of printf. And now this time we're putting in a function for A. So format here must be this whole function. So we just stick it in. And then we're like, okay, we have this IO function, which is too strict. Won't let us have enough freedom to do whatever we want with this string. So we generalize it to just be any type A. Then we kind of know by looking at our arguments that we've got here that this function takes a string to an A and a string. So we can kind of list our arguments here. And again, we only have one thing that we can do with those arguments. We have a function from a string to an A and a string. We need an A. We're already just going to apply that function. And that's our definition. What's really interesting about that is it's the same on the left and the right. So all this actually is the identity function. It is it doesn't look like it is when you're like using it, but it's just whatever you give it, it's going to give you back. Okay, so we got one more. So you can probably guess how this is going to go. printfd is an integer. It's waiting for an integer before you can do anything with it. We kind of replace the A's with the type that we're going to end up with. then we say, oh, okay, so I've got a format. This must be the type of format. I put that as my type for the function that I want. Then I kind of generalize it to work for any type. And then I'm going to write my definition. I have a function from a string to an a. I have an integer. Wait, this one's not as like obvious, but it's pretty obvious. So we need to turn our integer into a string before we can have an a. So we just show the string, show the integer, and now we get back an a. And that's our third formatter. Does that one make sense too? Okay. And you can do the same thing that you did with C here, and like try out different different functions as like its continuation, and see what happens. But it works just the same way. So now we have this question of how do we combine these formatters? And this is kind of like the trick, because the same formula doesn't work, right? For the pattern that we could have all sorts of formats, and we could have as many of them as we want. So the type up here is going to be different for every one. We could, it's going to be different if we have only one of those formatters compared to if we have three of them, and if it'll be different depending on which one we have. So it's a little bit easier to instead just think about, well, what do we want to do? What do we want this operator to do? The thing that we want the operator to do is to take whatever string the formatter formats, and we want to put them together. We want to concatenate them. So whenever I'm trying to work out a tricky function like this, I like to either leave an underscore like this, like a typed hole, or you could just write undefined. And you can just say, I don't know what this is going to end up being, but I know one part of it. And the part that I know about this one is that I'm going to put the strings together, and I'm going to apply the continuation to it. Oh, does it also make sense why there are 3 arguments to this function? It looks like it's a, what do you call it, binary operator, right? Because it's just between the two. But it's still waiting on another argument, right? That's the whole, and that's going to be the continuation. So it's got its left hand, its right hand, and then what it's going to do with the result. So it has 3 arguments. The format, the first format, the second format, and the continuation. So as a reminder, all the formats look like this, and they all look kind of similar. When you're actually using C, you're applying a string before it even gets to here. So when it actually gets to the percentage operator, it's of type string to A, right? And then S is string to A to string to A. And then D is string to A to int A. So they all have the same first argument, which is a function that says what to do with a string. So we can start writing some functions that say, here's what you should do with your string. And the way that I was thinking about this when I was writing it is that it's kind of like we have two functions that are like, I have a string and I don't know what to do with it. And then you have another person who's like, I have a string, I don't know what to do with it. And you have a third person who's like, oh, I really need two strings. And you think like, you should make something work here. So the first thing that we're going to do is we're going to give, format 1 is going to give its string to format 2, right? So now what format 2 should do is it has access to two strings. So now it can just call concat k because it has the two strings that concat k needs. And then concat k can put the here and apply the continuation. Okay? And this function is extremely ugly, but it works. Does that make sense? Like why this would work? Format 1 is going to do whatever it's supposed to do. Format 2 is going to do whatever it's supposed to do. Then it's going to concatenate them together. Cool. And let's just make it a little bit prettier. So we know that like what format 2 should do is just all it's going to do is concatenate the strings and apply the continuation. So we can just get rid of that and call that directly. And then I don't know if anybody's familiar with point-free style, but like each will just tell you don't need that argument. You can just compose these two functions, and then you can kind of replace that into the main body of the function. And probably make this even more concise. I just don't feel like it, and I think it's pretty readable right now. I'm a big fan of ugly code in a way, actually, just because it's pretty clear what it does, and you can get kind of distracted refactoring until something is completely unreadable, just personally. So I don't know, I'd encourage you to try out the formats in GHCI and just work. And I feel like probably ought to have some questions at this point, or I've like really confused everybody.
I have a question.
Mm-hmm.
The percentage the definition of the percentage function is that like implied by Haskell that it's like it's supposed to be using a infixed notation?
No, you can use it prefix if you wanted to. The way that operators, I'm not. Yes, you can. So I think you could say. And that would be the same as saying.
Yes, sure.
Yeah.
Here you're using actually the parentheses.
Yeah. So.
If you omit those parentheses around the percentage, it's like the first argument is supposed to be in front of this percent, right?
Right. Yeah. If I think it's like certain special characters are allowed to be operators, and if your function name is only those characters, then it's a valid operator. Like Sally, you can't make I don't know, you can't just make any like emoji into a function. Although you can actually make this one into a function, but yeah, it's only certain characters. You can actually use Unicode, I think, but those are not operators. Anyway, I'm getting distracted. Any other questions? Or thoughts about how this works? Okay, so my next question is like, how can we make the type of D more general? So right now, the way that we've defined the D function, it only takes integers. What if we wanted it to take decimals? Any ideas on how we could do that?
Type classes.
Yeah! So we can just make it, all we have to do is put like num n, right? Except that we also need to have the show type class because there are numbers you can't print to a screen, apparently. Are there math people who can tell me what numbers you can't use printf on? Or put stir on? Yeah?
It's not that there are numbers that you cannot print. It's that in order to use show, you needs to be a member of the show class. Otherwise, the show will not be defined on it.
Okay.
That's why you need two type classes, right?
Okay. Oh, so like it's not that. Oh, okay. So it's just like shows not. It's not like a restriction on number that it has to be showable. That makes sense. I'm sorry.
Because you need an instance. If you know that something is a num, you don't have an instance for show yet.
Right. Right. That makes sense. Okay. So we have to get a little more specific than just a number. We have to say that it's also show. And then you can say you have 2.5 cats for some reason. It's pretty gross. Okay. So what about if we wanted to make a formatter that worked for anything? Unfortunately, we can't do that because be turned into strings. But we can, as you may guess, just make something that is any show type. And now you can make your any type that you derive show for, you can show in your printf thing. Okay, does that make sense? Cool. So if we look at our printf types and we look at the fn types, I hope it looks a little bit familiar. The fn types are a little more complex because as well as kind of threading through, it's also kind of processing request, and you can even do I/O in the processing. So it's a more complex type. But then if you look at the type of the arrow operator, the first argument, just like in printf, is the same type as, or at least has the same structure as the type of that connecting operator. And the general pattern, the patterns in general. So yeah, I'm not gonna like completely explain because I actually have never tried to actually make this work, but it's basically the same thing. So does that make a little more sense about how the routing makes the types match in FN's handlers between the parameters and the routing? I guess like going back to the beginning. that whatever type this is matches that, just because the continuations say what to do with it, or it becomes the continuation of that side is expecting. Yeah, so that was my attempt at explaining how it works. If you want more details into how it works, you can look at Daniel's slides. I'm going to go ahead and paste those into Discord. Oops. Okay. And yeah, you'll see it's the same example. He goes into more detail about how the types he fills the types so that you can see how the types work out. So if you're curious about that, you can look here. But yeah. So now that we kind of know a little bit more about how the routing works, I kind of wanted to give you time to try things out, make your own routes and your own handlers. Try like some wacky stuff. If you wanted to try making your own from param instances, if you go, so this person over here brought up, like, he was curious if you could have params that are your own custom types, so that it's taking something that can be turned into a user ID or something like that. For that, all you have to do is make it an instance of this from param type class. So you can try that out. There's also with the response helpers, which are at the bottom of the documentation. So you can serve a static file, you can return text, you can return JSON, return HTML, and all these just take text. So like I'll show tomorrow using, which is a HTML library, but you can just like write some HTML for now. Yeah, just give it a shot.
Question on these, why are these maybe response instead of just response? For example, error text, I would not expect something like that to fail.
Yeah, this isn't really about failing. This is about so that your handler, so this ends up being the type of the handler, and the handler can choose not to return a response.
To fall back to another one, right?
Yes, yeah, yep. This is annoying though, because like a lot of times I want the error text to be like my fallback, in a way, but it's fine. Yeah, it works when you're like saying when you're just like returning it within a handler. Any other questions about how these work, or anything else? I mean, and I can just walk around and answer stuff, but. Yeah. Cool. Let me know if anybody has any questions. Just yell. And we've got like, how much more time? We've got like 20 more minutes or 15 more minutes. I'd also be curious like what people want to work on tomorrow. I was going to do Postgres Simple and Blaze. Well, I was going to do Blaze and forms so you can get input from your users, and then do databases. Does that sound good? Cool. Huh? More than forms? Yeah. Yeah. Cool.
Would it be maybe better to maybe
Do what?
just, I don't know if everyone will run Postgres. That would be tricky.
To do.
Run Postgres everywhere on everyone.
Yeah, it is tricky. So, I mean, one thing I thought about was like setting up an RDS database and letting people connect to it, but I haven't done it yet, so I wasn't really sure.
Does Haskell support SQLite?
Yeah, there's a SQLite library, I think.
And is it very different? Like, could we use the same API for working with Postgres and SQLite from FN?
I think the same library actually does have a SQLite backend or SQLite backend, but I'm not sure how well it works. I've never tried it. I've mostly worked with stuff that, or no, wait, I'm thinking of. Let me see. So this is a library that I usually use. I just like vaguely remember that there was. No, I'm thinking of Opali. Yeah, I'm sorry, I'm not sure. I'm not sure about SQLite. Or SQLite. Oh, this looks really similar. Oh, that's cool. Anybody having any trouble with making a handler that they want to make? Or any other questions? No, it's not right on mine either. It's just. Yeah, I think it's because the original presentation had it changed, so you had it missed. But it's. I think it's just this. It's going to change from this to this. Oh, if you want to see the slides for this, I'll go ahead and put those in as well. Oops. Yeah. Oh, I forgot to mention, a lot of the types in this are wrong. Whenever I annotated a type, and if I said something is of types int to int, that's usually a more concrete type than what GHCI will actually give you. But that's just because it's easier to understand concrete types. So if it looks different in your
I have a question about from para.
yes.
So it seems that the parameter type is one list of text.
Mm-hmm.
Why not text?
It's a type.
From para. It has a type, the parameter has a type that is a list of text.
Right. Why is it a list of text? I'm trying to remember. I wasn't actually expecting to address this, but this other person asked about it. Why is it a list of text?
Params with comma separated ones?
Maybe.
I would expect that it's a single parameter and it's just a string, but
Yeah, I would too. I'm going to look at what the definition is to try to understand why.
Do you want to
I know I ran into some trouble. I actually had somebody submit a pull request that I think is just still sitting around, where they were trying to make from param instance just for strings, and they ran into a lot of trouble, I think, because of this. So very interesting. No, that's not. Okay. Okay. Oh, So what it's doing is it's looking up, it's trying to find all the, so like let's say that you said like name equals Libby and name equals party, and you had multiple params that matched name. Maybe you want, what you want the result to be is a list of Libby party, right? In which case, like, you want to have both of those, access to both of those things. So that's why from param takes a list, because it's a list of all the matching params.
Okay, that's a bit obscure usage of
Historically correct and terrible.
Like in practice, I don't think I've ever defined this something, because I just use like the primitive types and then convert them. So. We've got a couple more minutes. Any other questions about how anything works, or? Okay. Tomorrow's going to be a little less less slides, and going to be more like making stuff. So hopefully that'll be fun. Thanks for joining.